Hello everyone, today in this video we'll be discussing the third module of CN, which is regarding the routing. And here before routing we need to discuss few concepts very important from exam point of view. Make sure you watch this video till the end, and if you watch this video till the end, you can easily score more than 80% marks. And hit the like button, subscribe to my channel, that helps me make more videos like this. And without wasting any more time, let's get started. We have 5 topics. First is the network layer services. We'll see what it is, a small topic. Packet switching, 2 types are there. Then we will discuss what is IPv4, IPv6, very important concepts. Then we'll discuss 3 routing algorithms and 4 routing protocols. Okay, so let's get started with the first one, network layer services. Okay, so network layer, you are aware of what is network layer from the module 1 and 2. You will be transferring the data, and in the network layer, the data is transferred in the form of packets. Okay, so there will be packets like this one. So in this form, the data will be transferred. Okay, so data will be present here, and in the surrounding data, 2 things will be there. Okay, so that is called as some extra information headers. We will be putting the information related to what type of data it is, like that kind of information we will be putting. This whole thing is called as a packet. Okay, and we'll be transferring the data in the form of packets. Okay, and the packet, when it is ready to send, it goes through 2 phases. Okay, when it is ready to send, it goes through 2 phases. The first is the routing and second is the forwarding. Routing means it will be having an information of from this point to this point, how it will go. It will go first here, second, third, fourth, fifth, sixth. This is called as a route. Okay, that is a routing, setting up the path of the packet. Second is forwarding. Forwarding means after setting the path, we will be sending the packet through that path. That is called as forwarding. And for forwarding, we'll be using a forwarding table, which will be having all the information, first this to this, next this to this, next this to this, and so on until it reaches the destination. Okay, that is called as the forwarding. So other services also include, the first 2 main services of the network layer are routing and forwarding, and other services are error control, to control the error, and flow control, how much flow is happening, and if there is a congestion means more flow has happened, what should be done. Quality of service means how to ensure that the quality of the packet is not reduced, and to implement some security algorithm. These are the services provided by the network layers. Okay, going on to the second topic, we have packet switching. Okay, it is used at the network layer because here the data is transferred in the form of packets. Why we use packet switching? Because we are using the packets and it is present in the network layer. In network layer we deal with packets, so we use packet switching. What do you mean by switching? Switching means from one point to another point, transferring. Okay, that is called as switching. So there are 2 ways in which you can transfer the packets. The first is the datagram approach, second is the virtual circuit approach. Let's discuss the first one, datagram approach. In datagram, it is connectionless service. This is connection oriented. So what do you mean by connection? In connectionless service, we will be having the network here. This is the source and this is the destination, and here are the routes present and the paths also present. So when the data are transferred, observe here 4 3 2 1 gets transferred, and any of these route it can go, any packet can go in any route and it will be reached here. When it reaches here, observe the order is different, 1 3 4 2, which is different from what we have sent here. In that case, this happens here is because the in datagram approach, the packet is considered as independent, and therefore order is not handled, so it will come out of order. So we require data in the form of order, right? If it is out of order means it is meaningless and it is a waste data. We need not require waste data, we require useful data, right? So to use the data, we need to have the order preserved. How do we do that? For that, we'll be using the virtual circuit approach, which is connection oriented service. Here it's very simple. What happens, only one route is defined and all the packets go through that route. Okay, that's all, nothing else. So here the packets are received in the order. To accomplish this, there are 4 phases that a packet passes through. Okay, 4 phases. How we achieve that? First is the setup phase. Setup phase means we will be setting up which path it is needed to be traveled. Okay, for that we will be sending a sample packet A to B. This is A, this is B, and from here to here a sample packet will be sent, so to know that the path exists and there is no issue in the path. And after the path A and AB sample packet is received, it will send an acknowledgement to the sender that the packet was successfully received. That is an acknowledgement phase. And after the acknowledgement phase, we will be transferring the data through the same route. After the transfer of data, we will tear down the phase, means break down the connection. Okay, so that was about the packet switching. 2 types were there, very important question from exam point of view. Moving on, we have IPv4 and IPv6. Okay, so what is IPv4? Each device connected to the internet. You have some phone, laptop, and tablet, and your friends also have the devices. All those devices have an address. Okay, to know in the whole internet your device how it is, like which device you have. To get that information of which device, we need to have an address, right? So each of the device has its own address. That is called as IP address, internet address. Okay, so The first version which was released is IPv4. In this, it is a 32-bit address that uniquely defines the connection of host or the router to the internet. Okay, so we used to use the IPv4 32-bit. Okay, and there are few concepts here. Address space. What is an address space? An address uses B bits, then 2 power B bits address can be used via protocol. Okay, understand carefully. Address uses B bits. B, let's take suppose as 4 bits. If an address uses 4 bits, I can have here 4 empty spaces. And how many combinations can be possible here? And every combination 0 and 1 can be possible. So every combination 0 and 1 means 2 into 2 into 2 into 2, that is equal to 2 power 4. How many bits I have? That much 2's power I can have, that many combinations, right? So if I have B bits, 2 power B addresses can be used. Okay, the notion will be as follows. This is the first, second, third and fourth. Okay, let's suppose that this is the 8 bit, another 8, another 8, 8, another 8. So 8 4 is the 32, 32 bits are there. Okay, and this is in binary representation, and this can be further condensed into the dotted decimal representation, and this can be further condensed as the hexadecimal representation. This is how the IPv4 address used to be specified. Okay, and there is the hierarchy in addressing. In 32-bit IPv4, it is also hierarchical because it is divided into two parts. Okay, first is the prefix and second is the suffix. Okay, so this is the prefix part and this is the suffix part. What does prefix do? It defines the network, which network you are connected to. What does suffix do? It defines the connection to the node. The specific node which we are connected, that is defined by suffix, and prefix defines the whole network, which network it is. Okay, this was the representation, prefix and suffix form. And here we have different classes of IPv4. Okay, there were 5 classes. Okay, you need to know about the 5 classes. Those were denoted as A, B, C, D and E. Okay, so in class A, the network length was 8 bits. Okay, 8 bits were there, 1 bit for the prefix and 7 bits for the suffix. In class B, 2 bits for the prefix and 14 bits for the suffix. The length was 16 bits, so first 2 and remaining 14 here. And C was 24 bits, so first 3 and remaining 21 here. In D, it was 24 bits. There was no prefix, only suffix was there because this was used where the network is all same. Okay, there it is used. Okay, and also it does not have a prefix because it can be used for multicasting. We need not require which type of network it is when we are using multicasting. Okay, and class E is called as the reserved. It was not used. It was same as D, but the usage was not happened. Usage of IPv4 only happened in these 4 classes. Okay, now the classful addresses failed. Okay, why? What was the reason? The first is the address depletion. As you can see, there are limited number of addresses which you can have in each class, so there was an address depletion. And two another concepts are there in the classful addressing, which is the subnetting and supernetting. Subnetting means if there is a very big space present which can be used, it will be further divided into small addresses and they can be used. That is called as subnetting. The reverse process is called as supernetting. Also, that also did not solve the problem of address depletion. Okay, so classful addressing failed. That's where IPv6 comes. Okay, now how does IPv6 solve this problem? In IPv6 we have variable length of blocks. Okay, we have variable length of blocks, so that how much ever we have required, that much only will be allocated. Okay, also prefix length is variable. We can have a larger prefix, but then we'll have a smaller network or vice versa. Okay, also how much prefix we are using, it's not fixed, so we need to define what is the length, right? We need to define what is the length of the first bits we have used. First B bits we have used, the length will be equal to B bits. Okay, like that. We'll be denoting it by a slash. At the end we'll put a slash and put how many bits we have used for the prefix. Okay, and another concept which we use here is the address masking. It is the way to find first and last address. Okay, what do you do by address masking? You find the first and last address. How do we do that? We use a 32-bit number in which the leftmost bit are ones and the rest bits are zeros. By using this one, we can easily find the first and the last address. Okay, here's an algorithm behind that, so we need not dive deep into it. Just knowing this is sufficient for us. Okay, next is the network address. For each network there is an address. We will be setting up and finding it using the table called as forwarding table. This forwarding table will have all the information from which node to which node the data is getting transferred, what network it is, what type of data is getting transferred, what is the length of the data. Everything will be there in the forwarding table. Okay, next is the block allocation. Once we have specified the network, we need to allocate some blocks of data for transferring the data, right? So that blocks are assigned by using notation. That all is handled by ICANN. Okay, Internet Corporation for Assigned Names and Numbers. Okay, block allocation is done by ICANN. Okay, so there are some types of block allocation as well. We'll be looking in few seconds. So address aggregation means what? A small address will be there. You'll be combining it with to form a bigger address. That is called as address aggregation. This is a process of combining the addresses to create a larger block. So there are special types of addresses also, the five types of special address. The first is the this host address. This will point to itself. Okay, 000032. It will use its own address. Limited broadcast address. It uses the last address which is present, and it is used for the limited purposes. Okay, it is reserved. Next is a loopback address. It will always remain as the destination address. Whenever we want to send something, this will be the default destination. And a private address is the one which are used by the for the private purposes, and multicast address is used for transferring the data to from one device to many devices. In that case, this address will be multicasted address. Okay. Next, we have the DHCP. Very important question. What is DHCP? Dynamic Host Configuration Protocol. Till now, we discussed that we'll be taking addresses, we'll be transferring data, but who will configure what address it is and how it should be used? That is determined by DHCP, which is Dynamic Host Configuration Protocol. It is a plug and play protocol. It's very easy to use. It has many users. Very important protocol. So here, what we do, the assignment of the addresses can be done automatically using DHCP. So whenever we allocate some block of memory, we need some address associated with that. That can be automatically done by using DHCP. That's the first advantage. Second is that it can be used to assign temporary address because all devices do not use internet at the same time. Suppose that there are 5 devices, okay, and out of 5 devices only 3 are connected to internet. The 2 are having the address assigned, but they are not using the internet. So until and unless they use the internet, this address can be used, right? So that address can be allocated some other devices which are requesting for the address. So whenever this is not using the address, you will be assigning it to them. That process is done by DHCP. Got my point? Okay. So there are this is the message format for the DHCP. There are a few things here: OP code, operation code, H type, H length, and H count. And here is the transaction ID, time elapsed, flags, and then we have different kinds of address like client address, IP address, server address, gateway IP address, client hardware address, server name, boot file name, and options. Okay, need not go into the depth. Just get to know that this is the format of the message what we are using in the DHCP. Okay, and there are some options included. See, last one is the option, right? So option will have the following things available. So DHCP discover or offer, request, decline, acknowledgement, negative acknowledgement, release, and inform. So what does these things denote? These things denote which stage the DHCP is present in. Is it the first stage, which is the discovering stage where the address is discovered, or it is an offer stage where the address is offered to the device? There is a request made to the device, request is declined from the device, acknowledgement is sent, acknowledgement is came as negative, released, and informed. So these are the different stages available, and whichever stage it is present in, that should be specified in the options. So that's why we have a sequence of DHCP operations present here. Okay, and these options will be specified here in the value. The length will be of 1 bit and the tag will be of 53 bit. Tag is used to specify some metadata of the DHCP protocol. Okay, that was about the DHCP. Next important concept is the network address resolution, NAT. Okay, what is network address resolution? See, just imagine the internet. It's connected with a lot of devices. Each device will have address associated with that, right? So it provides the mapping between the private and universal addresses at the same time to support virtual private networks. Okay, so there will be different networks present, which can be either private network, which is specified with a specific company or organization, and universal address is the one which is accessible throughout the internet. Okay, so those mapping is done by the network address resolution. Okay, and for example, here we have this 20 computers which are owned by a business. Suppose that a business owns 20 computers, and if it max only 4 are used for internet, okay, then remaining ones are have occupied the address but they are not using it. So the remaining IP address can be assigned to the other systems. This thing, and which systems it assigned, like for example I took 16 of them and assigned to other systems. Now I have to have a record of which is assigned to which, right? That mapping is done by NAT, network address resolution. This process is carried out by DHCP for assigning it, but the record keeping and the mapping, that is done by NAT, which is network address translation or resolution. Okay, this is about the IPv4. Next, let's have a look at the IPv6. Okay, so this was about the IPv6 only, the further concept which I explained. But here we'll discuss more into the depth what is actually the IPv6. Okay, IPv6 is needed because IPv4 did not provide the solution for address issue. As I discussed, address was limited and it was over, so we needed to have a mechanism in which the address solution will be provided. So few things were added in IPv6. Better header format, the header was good, there were new options present, and extension was possible, and resource allocation was possible, and there was more security. Okay, This is the packet format in IPv6. Very important question. Here we have the base header in the first part, and second we have the payload. Payload will have the actual data, and base header will have some information like the version and which class it belongs to, what is the flow label associated with that, what is the payload length, how much data you have, it's 1 MB, 2 MB, 1 GB, and so on. What is the next header, where it should get transferred, what is the hop limit, how many hops it can make before the data can be before the data gets destroyed. And here we have the source and the destination address. These all things come under this part, okay, base header. All this information provide a guide for this data to be transferred to the next hopper or next destination successfully, okay. So it has flow based on the label on the packet. It defines the path of the packet's flow. Using this, we can define the path. From here, it have to go to here. Next, it has to go to here. Next here, and so on till the destination. Okay. So it also uses fragmentation and reassembly. What do you mean by fragmentation? Dividing into smaller packets. So the main packet can be divided into smaller packets if necessary, and reassembly will be done after the task is accomplished, for which you have divided into smaller parts. When that is done, you will be taking up and reassembling it into the main packet, means the original packet, okay. Also we can have the extension headers. Apart from these headers, we can also have some other headers used for some special purposes. What are those? There are different kinds of 6 types are there, okay. The first one is the hop by hop. It is used when source need to pass info to all the routers visited by the datagram. So there is a source, there is a destination, and in between whatever the paths it passes through, that is called as the routers. And one jump, second jump, third jump, these jumps are called as hops. So in between the routers are present, right, on which the packet is jumping. If the packet wants to transfer the information to that routers also, in between we'll be using hop by hop. Destination means only if you want to transfer the data from source to destination without any of the intermediate nodes getting to know the data, we use destination. Source routing uses IPv4 routing concepts. Fragmentation divides the datagram. Authentication validates and ensures the integrity of the message, means it is authenticated, it is the right message. And encrypted security payload is for the security purpose, okay. Moving on to the fourth topic, we have the routing algorithms. Three routing algorithms are there. Listen very carefully. The here what we do in routing algorithms. Route means what? From source to destination, what is the best path? And what will be the best path always from one point to another point? The best path will be the one which will be having the minimum cost, right? The cost will be minimum. That is the best path. So here we use least cost routing to design the algorithm. We use three methods to find out the least cost. The first one is the distance vector routing. Each node creates its own least cost tree, okay. So nodes will be connected with the other nodes, and those nodes will be further connected with other nodes, right? So each of these nodes have a connection. So in each of these nodes we try to find out what is the least path to the other nodes, okay. That is what we use here. And we use a Bellman-Ford equation here. To reach from x to y, we have the following ways, and we choose the least cost one, okay. So we find out the minimum one from let's suppose this example, I want to reach from x to y. Now I have the paths either through A, B, or C. What I do, I add CXA plus DAY, that one, plus or CXB plus DXBY, and CXC plus DXY, this one. Like that, how many ever nodes are there, that many paths I will add and see which is costing me the least amount. So whichever is the least, that one I will select a minimum and assign it to DXY. So the path from X to Y will be that minimum one. Okay. So here we use a table of this kind. From A to A, what is the cost? 0. Obviously from node to itself it will be 0. From B to A, what it is 4. From C to A it is 2, and so on. Like that we store it in a distance vector. This is called as distance vector, okay. And like that we calculate for all the nodes, and then we find out what is the least path from the source to the destination. And here we use the Bellman-Ford equation. So first we assign the D vector here as 0. We loop from 1 to n, and if y is the neighbor, we will calculate the cost of y and store it here. And if it is not the neighbor, it can't be reached, so the cost will be infinity. And after you have done for all of these neighbors, send all of these neighbors to all the neighbors, so that all of the neighbors will be aware of what is the cost from itself to the other nodes, okay. After that, repeat forever until you find the least cost. Here what we do, we try to find out what is the minimum cost. Is it the straight path or a path through different nodes? See, is this shorter or this shorter, okay, that we are calculating here. And if there is any change, update the change and inform all the neighbors, okay. Like that we keep on doing until we find out the optimal path, okay. That is about the distance vector routing. Second is the link state routing. Here also we do the same thing, just that in all the nodes we have a separate table with the node and the, suppose that from C how many connections I have, B, F, and G. So I write the cost here. Like that we'll do for all the nodes and all the costs from all the nodes, and then we'll be putting it in a table form like this. And then we'll be using the distance routing, means the link state algorithm, or the it is utilizing Dijkstra's algorithm. Okay, here we will be using the Dijkstra's algorithm, which can be used for calculating the shortest path from the source to the destination. Okay, this is the link state routing. Okay, and third is the path vector routing. This is the last one which in the routing algorithms. In path vector routing, the priority is not the least cost. Okay, so you might ask me a question. Obviously, when we want to reach from source to destination, we'll be choosing the least path. Now, suppose that if I want the information to be transferred from this one to this one, source to destination. Okay, but there is some node in between. I don't want it to have the data. Why I don't want to have it the data? It might have some lesser security present, so I want to choose another path which might not be the least path but more secure path. In that case, I can use the path vector routing, which will not care about the least cost, but for reaching from one point to other point based on other factors. Also, it is concerned about the mere reachability. I don't care about the cost. I just want it to reach safely from one point to another point. In that case, we can use path vector routing. Okay, so it uses spanning trees here. Spanning trees will be having a path from one node to all the other nodes which it can reach, and the first path which finds the destination is taken into consideration. We will check from all the paths here which is the one which is reaching first, that one we will be taking. So in this case, ABDFG is the path. Okay, ABDFG is the path. That is the three routing algorithms. Based on these algorithms, we have the protocols. Okay, what is algorithm, what is protocol? Algorithm is the way of doing the things, and protocol is the actual implementation. So by using this algorithm, we have developed some protocols. Let's have a look. The first type is the unicast routing. Unicast means if you want to transfer the data from one point to another point, 1:1, that is called as unicast. Multicast means from one to many. Okay, from one to many. Okay, one to n, that is multicast. In unicast we have three types. Okay, first is the routing information protocol, or RIP. Okay, this protocol works on the information present within the routers. So from source to destination, there are different routers present in between, right? So what are the information present in these routers? Based on that information, we'll be doing the routing. That is called as routing information protocol. And here we'll be using hops. Hops, I already told you what is hop. Jumping from one node to another node. Okay, it means going to the next router. That is called as hop. Okay, and the cost of travel is calculated based on the least number of hops required. The number of hops which it is more, will not ignore, will ignore that, and we'll consider the one which is the least cost, means the least number of hops are present. Okay, and to put all this data into a table, we'll be using a forwarding table. And for the routing information protocol, it uses UDP, user data account protocol. It is not secure but faster, and we use the port 520. Okay, and let's discuss the algorithm. RIP algorithm works on the distance vector algorithm, the first one which we discussed, right? The distance vector algorithm, and some changes are required. It is same as this one, but some changes are there. In that, what we used to do, the distance vector, whatever we had got, we will send it to the neighboring nodes. But here, whole content of forwarding table is sent. That is one difference. Second is, based on the data received, router adds a new hop cost to the existing table. If there is a new hop coming in between, or we have a least cost lesser than the previous hop, we'll be taking that into consideration. Okay, finally, forwarding table is sorted and is used as a guide to transfer the packets from the source to the destination. Okay, we'll be using forwarding table every point wherever we have to go from one point to other point. That time we'll be using the forwarding table. These are the three changes. Rest all the algorithm is same. Okay, next is the open shortest path first, OSPF. It is similar to the RIP, but here we will be using the link state routing. There we used what? Distance vector routing. Here we use the link state routing, which is the second one, second algorithm. Each node can be assigned weight. There can be weights assigned to it, so that every of the node will be having some weight. Now, what is weight? Weight includes the factors which decide what is the weight of the node. Is throughput, how much output you are getting, what is the round trip time, what is the total time taken, and what is the reliability. Is it reliable or not? Also, the forwarding tables are used and autonomous systems are used. So forwarding table, you already know, it has all the information from the source to the destination, what are the paths and all. But what is autonomous systems? Okay, autonomous systems means it will be having a separate system here. Everything will be separately present here. Okay, and there will be connection between the routes present here. Okay, and each of these will be having its own algorithms. This is called as open shortest path first. Okay, OSPF uses autonomous systems here. Okay, each packet behaves autonomously. Okay, and there are 5 different types of links used. How many links are used here? 5 different types of link. This is link state routing algorithm. So obviously links will be there. There are 5 different types of links. Very important question. Router link. What do you mean by router link? Here is the network, and here is the route, and here is the another route. So link between the network to the route is called transient link. Link between the router to another device is called as a stub link, and link between the router and router is called point to point link. Okay, and this is called as network link. This whole thing is a network where the routers are attached to a device. Okay, and the third one is the summary link to a network. This is one area, this is one area. Like in autonomous system, these are called areas. This is one area, this is one area, and so on. So the connection between two areas is called as a summary to the link to the network, and summary link to the OS means directly we are going for the open shortest path. So here the link between the area and another autonomous system is called as a summary link. External link is from one area to another device. Okay, so these are the different things which you need to know in the OSPF. The autonomous system is very important. After that, we have the border gateway protocol version 4, BGP4. Okay, so here we will be having the inter-domain protocol. Till now we discussed the transfer of data within a domain from a source to destination which is present inside one domain. Now we will consider if there are different domains present, how is the data getting transferred. So it is inter-domain protocol between different domains. It uses path vector algorithm, and it is used for connecting different domains. Okay, so here this is one domain, this is one domain, this is one domain, and so on. All these are connected via the routers make the connection, and the data is getting transferred between them. And there can be two types of BGP sessions, eBGP and iBGP. eBGP is the external BGP which is used constantly in the connecting the external systems. It is used to connect external systems. This session is called as eBGP. If it is between between the same network, it is called as the iBGP, which is internal BGP. Okay, here also we use the forwarding table, and also it is used to keep the track of the connection paths. Why we use forwarding tables? To have the information what is connected with what, right? So that's why we use forwarding tables. Apart from the forwarding table and hop and cost, like these kind of properties we have in the previous algorithms, but here we have a very important property which is a path attribute. This is a repeated question exam, make sure you know this very well. So what is a path attribute? Since it's an external connection, see, if this is the same network, we need not have the network name present and which type it is, and all those things are same for all of them, right? So we need not have it in a separate place kept. But if it is two different system, we need to have some external information, what network it is and what type it is, where it is, and what is IP address of different networks. Because systems are different means obviously more information will be required. So we use path attribute. So what all it can consist of? It is of two types, well known and optional. In well known path attribute, it is to be recognized by all routers present in the system. Optional means it need not be recognized by all systems. Okay, well known is the mandatory information which all the routers needs to know, and this is the one which if they know also it is good, if they don't know also it is fine. Okay, and the format of path attribute is as follows. Here four main things are there: O, T, P, and E. What is O? Optional bit. Is it optional or not? That bit is specified here. Partial bit, this is having some more complex information about the partiality. And here we have the transitive bit. This transitive bit has further types here, four types, I mean the 7 types are there which we will discuss. And here we have the extended bit. Is the system extended with the other system or not? And attribute type and attribute value length is present based on the attributes, and here in between zeros are present. Okay, this is the format of path attribute. Now there are four kinds of messages which can be used: open message to start a connection, update message to update some information, keep alive message to extend the timeout, or else the connection will be broken. To make the connection broken postponed, we will be using the keep alive message. Notification, if any error is there, there will be a notification. Okay, so the transitive bit, there are no there are different types are there, but I have not included in this note because it will become more technical. But you can go through the notes. There are 7 types are there. Just for the information you can get to know. Okay, but it will not be asked from the exam point of view. This is what will be asked in the exam point of view: the types of messages, the format path attribute, 2 types of path attribute, and this whole thing comes under the BGP, right? So there are different types of BGP also. All those things are important from the exam point of view. Okay, eBGP and iBGP, different types of BGP here. Now, moving on, we have the multicast routing. Here we have the one type of algorithm protocol, which is the multicast open shortest path first, or MOSPF. M is the multicast, OSPF is the same as the previous one. So whatever the points were valid for OSPF, here also it is valid. Slight changes will be there here. Okay. So multicast, if you don't know what is multicast, it is for transferring information from one node to multiple nodes. That is called as multicast. Unicast means one to one. Okay. So what is the algorithm? The router uses Dijkstra's algorithm to create the shortest path tree S as root. Okay, root is what? S, and to all other nodes as leaf. Okay, so it creates a subtree for transferring information in bulk. Okay, and router finds the shortest path from step one. Here the tree is created from the tree. What is the shortest path that will be taken, and that will be used for broadcasting. What do you mean by broadcasting? See, in multicasting, we need to transfer data from one node to many other nodes. That is called as broadcasting. Okay, so the subtree which is created by the shortest path, that can be used for multicasting. Okay, and the router can forward packets only to those interfaces of those corresponding to the branches of the multicast tree. In that tree which is created, what are the branches present? If the branches are connected to the leaf, for that only the data gets transferred. Okay, so example, if we see here, see the example initially, this is the graph which is given, or the tree which is given to us, and initially it will be like this. Everything is connected with each other. Okay, then what we do, we find the shortest path from all the nodes. From this node, the shortest path to here is this, to here it is this, from here it is this, from here it is this, and from here it is this, from here it is this. After that we need to find the shortest path from source to destination. Okay, for that we remove the redundant ones. This is the redundant one, right? Because it's not leading to anywhere, so I'll remove that. After I remove that, this will become the redundant one. Why? Because I can reach to this point through this place here, right? I can reach through here, and this will become redundant one. I'll remove this one also. So in this path, I cannot remove any of them. Why? Because if I remove any of them, the connection will be lost, and source to destination there will be no connection. Like that we will do for all the nodes. This I showed you for one node only. Like that, many nodes will be connected, right? For all those nodes, what is the shortest path, that will be taken into consideration, and at bulk all the data will be transferred from one node to all the other nodes. That is what multicasting is, right? From 1 to n. Okay, that's how the MOSPF works. Okay, so this is an example. That's all for this video, and if you found this video helpful, please do like and subscribe. That helps me make more videos like this. And thank you so much for watching. I'll see you in the next one.